Hello, friends. Grab your coffee, grab your cookie, and today, maybe step away from any barn, seed mill, or open field, because we are exploring one of the most misunderstood groups of airborne contaminants, natural dusts. I am talking about soil dust, salt dust, organic plant dust, seed dust, flower dust, poultry dust, livestock dust, and biological decomposition dust. These dusts seem harmless because they are natural, but from an engineering and health perspective, they can be just as dangerous as industrial mineral dust. I am Michael Klepik, and for 15 years I have been designing dust collection systems for agriculture, seed processing, livestock operations, and environmental plants. Let's break down the real science behind natural airborne particles. What natural dusts really are. Technical description. We group them into three scientific families. First, mineral earth dusts, including soil dust, wind-blown sand, salt crystals, and clay fines. Particle sizes range from 1 micron to 100 microns, with bulk density from 1,000 to 2,000 kilograms per cubic meter. Second, organic agricultural dusts, including seed dust, flower dust, pollen dust, and dried plant fragments. Particle sizes range from 0.5 microns to 50 microns, extremely lightweight and highly allergenic. Third, biological and animal origin dusts, including poultry dust, livestock dust, manure-derived particulate, feather dust, bacteria-laden fine matter, and dried organic decomposition products. Particle sizes range from 0.3 microns to 20 microns and may contain biological contaminants. These three families behave differently, chemically, biologically, and aerodynamically. Where these dusts are generated, you will encounter them across agriculture and the environment. Soil dust appears during plowing, milling, crushing, excavation, transport, and construction. Salt dust appears in salt mining, feed mixing, drying operations, and even coastal environments. Seed dust appears during cleaning, bagging, grinding, sorting, and seed coating. Flower dust appears in processing of herbs, teas, spices, or decorative plants. Poultry dust appears in egg farms, feather removal lines, ventilation systems, and bedding changeouts. Livestock dust appears in cattle barns, feed processing, manure drying, and bedding materials. Biological waste dust forms when organic material dries, breaks apart, and becomes airborne. Natural dusts are everywhere, but their risks are often underestimated. Why these dusts are dangerous to human health? Each family poses unique risks. Mineral earth dusts can contain crystalline silica, causing lung damage. Salt dust irritates skin and respiratory tissue. Organic agricultural dusts contain proteins, allergens, fungal spores, and plant chemicals that trigger asthma, allergic reactions, and hypersensitivity pneumonitis. Biological dusts may contain bacteria, endotoxins, dried fecal particles, ammonia residues, and feather particulates, causing chronic respiratory illness and infections. Natural dust is not harmless, it is simply unregulated in many settings. Combustibility and chemical behavior. Combustibility varies widely. Mineral dusts like soil and salt are non-combustible. Organic plant dusts are highly combustible due to cellulose and plant oils. Seed dust explosions are common in agriculture. Biological dusts can become combustible when mixed with feed, bedding, or grain dusts. Many people do not realize that farm dust can behave like explosive grain dust. Behavior in airflow. From an engineering perspective, soil and mineral dusts settle quickly unless duct velocities are high. Salt dust absorbs moisture and cakes inside ductwork. Seed and flower dust are extremely aerodynamic and stay airborne for long periods. Feather dust forms fluffy clusters that clog filters. Biological decomposition dust behaves like fine smoke, carrying odors and microorganisms. Every family requires different duct velocities, filter media, and handling strategies. Best filtration equipment for these dust families. Torch air uses different approaches. Mineral dusts, soil, salt. Blizzard standard Baghouse or Blizzard AR Baghouse for abrasive conditions. Organic agricultural dusts, seeds, flowers. FOEA and Cartridge collector with membrane filters for lightweight fibrous particulate. Biological and poultry dust. Passat bioparticle cartridge system with antimicrobial coatings and pre-separation zones. For mixed environments, I often combine Baghouse plus Cartridge pre-filter cartridge system plus HEPA polishing section. Odor control stages for biological materials. Natural dusts demand engineered filtration, not improvisation. OSHA and NFP compliance requirements. These dusts touch several regulatory frameworks. Silica exposure rules apply to soil dust containing crystalline silica. OSHA agricultural exposure guidelines cover seed, plant, and biological dusts. NFPA combustible dust requirements apply to organic agricultural dusts. biohazard guidelines apply when poultry and animal waste are present. Even natural dust is heavily regulated once it becomes airborne in industrial volumes. Dust collector system design. For natural, organic, and biological dusts, I designed first, differential pressure sensors to monitor filter performance with lightweight and fibrous dusts. Second, automatic hopper discharge into super sacks for high-volume soil or salt dust. Third, sealed discharge into plastic-lined containers for biological and poultry dust. Fourth, HEPA secondary filtration for environments with bioaerosols. Fifth, abrasion-resistant duct elbows for mineral and sand-based dusts. Sixth, odor control and antimicrobial sections for livestock and poultry operations. Seventh, high-velocity airflow and pre-separation for fluffy feather dust and seed husks. This system-level approach protects workers and equipment in agricultural environments. Soil dust, salt dust, organic seed dust, flour dust, poultry dust, livestock dust, and biological decomposition dust may look natural, but they are far from harmless. They are abrasive, allergenic, bioactive, sometimes explosive, and capable of causing long-term respiratory damage. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, nature is beautiful, but not when it's floating inside your breathing zone. See you in the next video.